All right, what's going on, guys? I had a couple of students email me about some of these problems. Unfortunately, I did just record a video and it glitched out halfway and stopped recording again. So I'm not going to go over as much as I did earlier. I'm just going to go over number three and number four. Number four is going to be real quick, but number three is going to take a few steps. Before I do move on, I just do want to tell you guys this is going to be a kite here. I want you to figure out and try it yourselves, but if you can reason out why it's going to be a kite and you get kite, you did a good job. But first, let's go ahead and take a look at number three. So my first step that I'm going to do here is, again, we always want to check first, before we even do anything else, what we want to do is we want to go ahead and just graph out this shape. So if this is G, this is I, this is V, and this is E, right? We've got a quadrilateral, could be an isosceles, or it could be a triangle, or not a triangle, it could be a trapezoid. It kind of does look like a trapezoid, doesn't it? But we can't just say it's a trapezoid, we have to prove that it's a trapezoid. So let's go ahead and see if we can prove. I mean, I think it's a trapezoid, but let's take a look. Let's prove it. So my first thing that I'm going to do here is first let's pick a pair of opposite sides and see if we can prove whether these are going to be parallel. So I'm going to take, if the slope of IV, if that slope of IV is going to be parallel to the slope of GE, then I know that I've got one pair of opposite sides. So let's check that. IV, remember that for a horizontal line that we have here being 0 over 3 and 0 over 5, this here, these are going to both have a slope of 0. Right, horizontal lines, remember if you're walking on a on a 0, on just a plain ski slope with skis, you're having no fun. You are not having any fun. So this is 0 slope. Now I'm going to check my other two slopes, my slopes of GI, and I'm going to ask myself, are these parallel? Yes. I'm going to ask, is slope GI parallel to slope VE? Well, let's take a look. Remember, going left to right, I'm going up, and it looks like we're going up 4 over 1. So my first slope here is up 4 over 1, and left to right looks like we're going down, so we're going down 4 over 1. Are these parallel? No, right? Negative 4 over 1 is not parallel. Matter of fact, they're not even perpendicular. They're nothing to each other. So here, big red X, these are not. Knowing that, right, we know that this has one pair of opposite sides, so it has to be a trapezoid. It could be a regular trapezoid, or it could be an isosceles trapezoid. I don't know until I find the leg length. Now, the best way of finding the leg length is, you could always use slope, being up 4 over 1. But a lot of students get really confused when they see, well, I had down 4 over 1. And they really have a hard time saying that those are congruent, right? But the best way, at least for me, to find the length of those legs is by making a triangle here. Oops. Making a triangle here. And then making another right triangle here. And then finding my hypotenuse. Now, how do I know that's my hypotenuse? Well, I made a right triangle. Remember when we did trig, I told you guys there's right triangles everywhere. So here I know that this is my opposite side, so of my 90 degrees. So this is, I'm going to say that's C1 and this is C2. Now my length here is 4, right? Look, we went 1, 2, 3, 4. We went 4 up. Now, some of you are going to want to say, well, then this is -4. But that's not the case, right? This is not -4. Because right now we're talking about side lengths. We are not talking about slope. We're not talking about rate of change, right? If I were to take 4 steps back, I still took 4 steps. This is a length side. I am not trying to compare the rate of change, giving me -4 over 1. So because this is a triangle, being a triangle with a side length of 4 and 1, and I have a side length of 1 and 4, these are the exact same triangle, right? And we can prove that using the Pythagorean theorem, right? A squared plus b squared equals c squared. Well, if I do the left one, I say well, that's 1 squared plus 4 squared equals c1 squared. Then when I add these two together, I get 1 plus 16 is c1 squared. So the square root of 17 has to be my answer. And again, because if I were to do 4 squared plus 1 squared, that's still 17. That means that the square root of 17 is also my C2. So my second step was to check, are the legs congruent? And in this case, we proved yes, they are congruent. These are indeed congruent, right? We proved it right here. And yes, I didn't do all the work for the second one, but that's just because the sum of two numbers, if they're both positive, we don't, I mean, for the sum of two numbers, it doesn't really matter the order, right? 3 plus 4 is 7, 4 plus 3 is 7. 1 squared plus 4 squared is 17. 4 squared plus 1 squared is 17. So here, these legs are congruent. So what I would say here is my first step would be, oh, because one pair of opposite sides are parallel and legs are congruent, this is an isosceles trapezoid. That's it. Now, this problem number 4 is going to go by fairly quickly. And the reason being is because, actually, I don't want to spoil anything. Let's go ahead and just draw it. So -7, -1, this is S. -3, -2, that's L. -3, +2 is L. -1, -6 is E. And then -6, -7 here, that's D. So let's go ahead and draw these up. -1, -6. And I'm just always going to, before I do anything, I am going to double check all of my points. Ah, look at that. I made a mistake right in the beginning. I bet some of you guys are probably like, Martinez, what are you doing, man? -7, -1 should have been up here. -7, 1. And that's why even when I'm doing and I'm creating these things, I'm always checking for mistakes, guys. It's really easy to get mixed up with some of those negatives. So just go ahead and always be checking for your mistakes. I don't know why that one keeps clipping there. Okay, wonderful. So I've got my quadrilateral right here, and this kind of looks like a trapezoid, doesn't it? But let's go ahead and double check to make sure that it is or is not. Remember that my first step is always going to check to see if opposite sides are parallel. Are they parallel? Okay. I'm going to start off with SL and DE. Up here, I completely forgot. You guys could have done that if you wanted to, but you don't have to worry about it. Are these parallel? Well, let's check. SL is going to be up 1 over 1, 2, 3, 4. Okay, SL was super easy. Slope of SL, 1 over 4. Is that parallel to slope of DE? Okay. 1, 2, then up 1 over 1, 2, 3, 4, 5. Perfect, 1 over 5. Are these parallel? No, they're not. Right? They're not the same. They're not parallel. Great. So that means for sure this is not going to be a rectangle, this is not going to be a rhombus, and this is not going to be a square. So let's see. What can it be? It could be a trapezoid, it could be a quadrilateral, it could be a kite, and it could be an isosceles trapezoid. Actually, it could not. Yeah, it could still be. No, it couldn't. But again, it could be something, right? So now let's go ahead and check SD. Are these parallel? SD and LE. Well, let's take a look. Is the slope of SD, what is it? Well, left to right, this is going down 3, 4, 5, 6, 7, 8 over 1, minus 8 over 1. Is that parallel to slope of LE? Well, LE is 1, 2, 3, 4, 5, 6, 7, 8. 8 over 2. Negative 8 over 2. So this is negative 4 over 1. That doesn't seem right, right? Well, let's take a look. 1, 2, 3, 4, 5, 6, 7, 8 over 2. Yeah, we were right. Negative 8 over 2. So knowing this, yeah, this is not going to be a parallel. These are not parallel, right? And because these are not parallel, it means has to be either a quadrilateral or a kite. Okay, so now let's go ahead and check. The second thing we have to do when we're checking this, right? A lot of you probably wanted to jump straight to a quadrilateral, but remember, kites don't have opposite parallel sides. So that means we have to check our diagonals. A kite always have diagonals that are perpendicular. So if this is not perpendicular, then this has to be a quadrilateral. Are diagonals perpendicular? Well, let's take a look. The slope of SE, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Minus 7 over 6. Wow, that is terrible. Let me double check here. 1, 2, 3, 4, 5. Oh man, this came up. What the heck? 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5, 6. Yeah, negative 7 over 6. That's really, really ugly. All right, so now let's check a look DL. Let's take a look at DL. So DL, is this perpendicular to DL? 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. Positive 9 over 3. Hey, that's 3 over 1. Yeah, that doesn't look parallel at all, right? So because because these are not perpendicular to each other, then here we would just say, okay, these are not perpendicular, therefore this has to be a quadrilateral, right? Why? Well, reason one is that we have no pairs of opposite sides, opposite parallel sides. And then my second reason is diagonals are not perpendicular. That's it. Because of that, it's quadrilateral. All right, so that's it. That's all I got for you guys. Again, you guys get kite for that. You did a great job, and you can do the rest. Again, send me as many questions as you guys want on this review, and I'll go ahead and make a video and post it, and hope that it's helpful for you guys. I will see you guys tomorrow. Have a great day.